So first up is question number 2, where it gives me this graph and it asks for the domain of the function using interval notation. So my domain, remember, is my x values from left to right. The graph goes right to the end of the page, which implies that it goes all the way to the left and all the way to the right. So using interval notation, that means I'm looking at negative infinity to positive infinity. Part 2, stating the range. Remember, range is your y values, and we go from the bottom of the graph to the top. We're again asked to do it in interval notation. So because my graph, again, goes all the way down, I'll start at negative infinity. And my highest point, or my largest y value, is a positive 2. And it does look like it touches positive 2, so I'm going to use this square bracket. All right. Problem number 4 asks, are these two inverses of each other? If it's hard to tell, remember that inverses always reflect over the line y equals x. It's easy for me to tell now that because these graphs do not reflect over this line, I'm going to have to say no, that they're not inverses of each other. I can tell easily they don't reflect over the line y equals x because their intersection point is not along that line y equals x. Because it's not, I have to say no. So number 10 gave us this word problem. Picking out some key pieces, they gave me the equation of the mountain, and they gave me the equation of the tunnel. And they're asking us to solve for y, which is the height above sea level where the cars would enter and exit. So they're wondering, what are these 2 points? And they even show you in the diagram that you're looking for the intersection between the mountain and the tunnel. So finding the intersection of simultaneous equations or system of equations, you can solve by elimination. If you choose to use elimination with this one, eliminating y would be easier. If you wanted to solve with substitution, that would be pretty easy for this one too, because your y's are isolated. So you could take this equation and sub it into the y of this equation to solve for x and then solve for y. But what might be easiest, especially with this one, since the y's are already isolated, is graphing. So I've already typed both of these into Desmos. And again, we're looking for the intersection points. So I'm looking at this point and this point. Remember, the graph or the question only wants the y values of those points. So we're looking at 3 and we're looking at 4.667. So I could just say y equals 3, comma, y equals 4.667. So Mathspace says no, but we might want to double check. Did I type things incorrectly? Yes. Did I look for the right points? Yes. So if you know your values are correct, think about instead how you typed them in. And I'm going to read into this a little bit, but sometimes that's just what you have to do with Mathspace. So reading into it a little bit, this decimal, 4.667, usually I only go from 6s to 7s when it's been rounded, meaning instead of 4.667, this could have been 4.6 repeating. Well, I know 0.6 as a repeating decimal, instead of a decimal as a fraction, is 2/3. Mathspace makes us redo a little bit. So I could write it as 4 2/3 instead and try that. And Mathspace says, yes, that works. You could have also written 4 2/3 as a mixed number or as an improper fraction, as in this case, 14/3, and Mathspace would have taken that as well. So they just always want, unless specifically stated, they always want exact values rather than rounded values. So question number 11, they're asking us to consider these parabolas with the given equations and first solving for the x coordinates of the points of intersection. So again, points of intersection implies that you are solving a system, even though they don't have it set up as what maybe you're used to seeing with the curly brace and the two equations. They still are giving you two equations and having you find a point of intersection. So just like question number 10, you can solve this using elimination, substitution, or graphing. Also, just like number 10, y is already isolated here, so I went ahead and graphed these in Desmos. Since I have two graphs, I'm looking for their intersection point, which means I'm looking for this intersection point and this point. All right, so now again, I'm looking at these decimals and I'm remembering, just like in question 10, usually Mathspace likes exact values rather than decimals. So I'm going to try to put these in because I'm not sure what 0.162 is as a fraction, or maybe it's a non-terminating decimal that there's more to it than that. So I'm going to try those x values first. I'm trying to submit them. So Mathspace says no, because they're decimals, and that tells me that there's more to that decimal than Desmos is telling me. So what I'm going to do, instead of solving it graphically, even though usually that's our preferred method, it doesn't always get you an exact value. Usually when you solve by graphing, it gives you an estimate. So instead, especially because they're asking me for the x coordinates first, I'm going to use substitution only because, again, both of these y's are isolated. So because y equals y, right? That's kind of a silly statement. But because y equals y, that also means that the right-hand sides of both equations are equal to each other. So I'm going to start with x squared minus 14 equaling 6 minus x squared. And I'm going to use this equation to solve for x. So I'm going to bring 1x squared to the other side. I'm going to choose to add x squared to both sides. So I'll have 2x squared minus 14 equals 6. I could have done it in that step, or in this step, I'll add 14. So I have 2x squared equaling 20, dividing both sides by 2. And then taking the square root. Right. So two things when I take the square root. Number one, and it helps that we had already graphed this. We know there's actually two x values here. So I need to remember that when I take the square root, I have plus or minus. Square root of 10, number one, 10 is not a perfect square, so I know it itself cannot just disappear, but I also can't split it up into something that is a perfect square and something that's not. So I can't simplify this at all. So this is what I'm looking at as my solution. So back into typing in Mathspace, I'm going to say x equals, I can even use the plus or minus button, with the square root of 10. Or you could write it out twice. 1 equals positive 10, 1 equals negative 10. Stating the points of intersection. So you could use this with either equation to then go on to solve for y. But looking back at our Desmos, y at least was an integer. So I don't need to do substitution to solve for y. I already had it in my graph. So I'm going to use those instead. I'm going to say 1 point of intersection. Point means ordered pair. Could be negative square root of 10 with that negative 4. Oops. My second point of intersection, separated by a comma, would be positive square root of 10 with another negative 4.